Hello everyone, my name is Alok Kumar and I am a student of Thapar University studying in ME Information Security 2013 batch. My supervisor name is Dr. Maninder Singh. Firstly, great thanks to him. It wouldn't have been possible without his help. Now talking about my thesis topic. My thesis topic is social media spam detection using fuzzy string matching. So firstly talking about the agenda of the video. So we will be talking about what is spam, what is social spam and why this change in trend. Then we'll be talking about classification of social spam detection techniques. Then some literature survey over the topic. Then we will talk about the proposed framework. Then the implementation of the proposed framework. Then the results. And finally conclusion and the future work. So firstly talking about what is spam. So spam is sending unwanted messages, especially advertisements, to any user. They become famous from email spam and has spread from there to all other medias. 2011 report suggests that spam messages was around 7 trillion and that too without operating cost. In 2011, another report shows spam volume originating from countries, and in this report India was ranked first, followed by Russia and Vietnam. So we can see the ill effect of spam, and that's why I'm working on spam detection. Now talking about what social spams are. So any spam message over a social network can be termed as social spam. It can be messages in bulk or links which are malicious, fake friend request, or any other hate speech over a network. Social spam include contextual information. That's why they are more effective than email spams. And the main problem with the social spams are that no effective technique is made till date for 0-day social spam attacks. And that's why social spams are very much lethal. Various detection techniques have been given till date for social spam detection, and they can be classified mainly in two types. Firstly, a link-based detection technique, and in this technique, it detects the spams using the nodes and the graph created by human established trust relationship. And the second is content-based detection techniques. Content-based detection technique uses the content of the user for detection, including messages, profile information, and the URL. Now talking about some previous work. So Lin et al. In his technique deployed honeypots in social networks and used machine learning to detect spam. In another work, Benvenuto et al. Gave techniques which use the user-based social network and the video-based features to detect spams in video social networks. The above two techniques are based on supervised machine learning, which have some inherited drawbacks, just like labeling of the training set, and this labeling has to be done again and again after some time. In another work, Charles et al. Used the content-based and the behavioral-based algorithms, where on the basis of similarity, a score is given which is used to find the clone profile in social networks. But these type of techniques cannot detect spams from the compromised accounts. In another work, Lin et al. Gave an exact string matching technique which can scan each message for spam. Here author extracted features from the messages, and these features are fed to machine learning algorithm to classify the spams. But the problem with the technique is spammers can easily bypass the technique by even a small change in a message content. In another work, Chris et al. Found all the spam messages contain words like free ebook, music, games, books, etc. He also gave a table which included percentage of each spam content in a spam messages. Using this table as a ground reality, we propose a new technique that is based on a fuzzy string matching, and that classify the spam from the message stream. So now talking about the problem statement. From the existing techniques, we can know that the need of the hour is to create an unsupervised, distributed, and a decentralized technique for detection and removal of spams from the social network. In our case, spam detection is treated as a binary classification problem, which either a message is spam or a non-spam. For detection, various features are to be extracted from the message, which can be used to detect spam from the normal messages. Our technique uses fuzzy-based method for detection, which can even detect spam messages which are being obfuscated by the spammer. Now talking about the framework of the proposed technique. So firstly, the tweets are collected, and these collected tweets are fed to the feature extraction point. Here, lexical and the status features are being extracted from the tweets, and these extracted features and the collected tweets are fed to the MapReduce platform. Here, firstly, the data is split and is being mapped to various mappers, and sorting is done over here. Then the data is assigned to reducer, and reducer reduces the data and produces the output. Here, output can be either a message is spam or a non-spam, and all of the results from the reducers is being merged to produce a final output, which include two sets of spam messages and a non-spam messages. Now talking about the implementation of our proposed framework. So the dataset was created using a Twitter stream using a Twitter API. Twitters which were of English language and contained URL were only kept. Machine was also set up to run the framework simple or even multi-core and multi-thread variations. For implementation of MapReduce variation of the framework, we firstly configured the master node to run a mapper and a reducer over it. Slave nodes were also configured, which can be controlled by the master node for further use. Now talking about the result, and here we train our proposed technique and compare it with exact string matching technique. So talking about the first table, so here we took a data set of around 13 lakh tweets, and exact string matching technique detected around 41,000 spams. Our proposed technique detected 43,800 spams, which included the original spams and some false positive too. But we can see that it required a much larger time. Now we modified our dataset, and here we changed all the spam messages. Just like a free word can be changed to FRE @ and now when this modified dataset was fed to the exact string matching, it wasn't able to detect even a single spam. But on the other hand, our proposed technique that used for this string matching detected the same 43,800 spams. But in both the scenarios, we can see that fuzzy string matching technique is very much slow when compared to the exact string matching. To speed up the process, we exploited the multi-core and multi-thread feature of the CPU, and in the final table we can see that the spam detection rate is same to the above, but the time required has significantly decreased, and in our case multi-core outperformed multi-thread. To handle large databases and large networks like Twitter, we molded our framework to work on a MapReduce platform, and results are as follow. The dataset used in this case included total of 36,000 messages, which had around 6,800 total spam. So when this dataset was fed to our MapReduce variation of framework, we set our similarity level to 0.80, and it was able to detect around 4,200 spam messages. To further improve the detection rate, we lowered the similarity level to 0.70, and now it was able to detect around 5,900 spams. But if we further try to improve the detection rate, it increased the false positive exponentially. So we finally set the similarity level 2.70. These were the results when we ran our variation on a single node. Now running our framework over multi-node variation. So to see the actual advantage of a MapReduce, we need a large data set, but here we have used a small data set. To mimic a large data set, we have used multiple instances of the same small data set. So here 10x means that same data set has been used 10 times, and in the same way x20 means we have used 20 instances of the same small data set. So these were the results when we ran our framework and data set. So what can be concluded from that big table? So first finding of the work was that when we increase the size of the data set, the time required by a node increases linearly. And this can be seen in the first graph on the left side, that there is only a linear increase in the time and it's not exponential, which is a good finding. Now talking about the graph in the right side, and it shows when we increase the number of nodes, the time required decreases, but after a certain point of time the required time start increasing again, and that only because of the increased overhead. Now talking about the highlights of our research. So we formulated a fuzzy based technique for detection of a spam from the message string. We used a content based technique which helped us to catch spams from even a single message, and that can also catch spams from compromised accounts. Use of fuzzy method helped us to catch spams which are even being obfuscated by the spammers, and fuzzy based techniques is very slow. To solve the problem, we exploited the multi-core and the multi-thread feature of the CPU. Implementation of a technique over MapReduce platform helped us to handle large data from networks like Twitter. So finally talking about the conclusion and the future scope of our research. We proposed a new technique which is based on a fuzzy string matching and which can even catch the obfuscated spams and more importantly spams from the compromised accounts. The technique uses MapReduce platform for implementation, which makes the technique able to handle large data set easily without becoming a bottleneck for the network. The false positive and the false negative of the technique was very low, and the variation in time of the nodes also showed that the time required to handle a data set also decreases when we increase the number of nodes. Now talking about the future scopes of the research work, the technique can be altered to use machine learning at the place of static dictionary for catching the spams, and moreover the technique can also be implemented using GPU, which can further speed up the process. Thank you for your time, and thank you.